Everyone, welcome to class number 4. In this class, we will discuss about subnet mask in IPv4 addressing. So let's take an example of a company network. So there will be many types of devices. It could be like computers for users, servers for the applications, or peripheral equipments like security cameras, printers, smart TVs, or anything like that. So when we try to establish a computer network, if we take a given IP address space, if we allocate randomly for each device, it will not be easy to organize them or manage them. So for that purpose, we need to allocate a specific group of IPs based on the device type or based on the device purpose, so that we will be able to manage the IP address space very organized way. So that is the first purpose of when we try to assign IPs to any machine, we need to have them in the groups. So that is the first purpose, to group similar type of devices with a similar IP address. Then the second purpose is limiting the broadcast address. So broadcast we discussed in the previous class. So broadcast is something communication from one device to all the devices. So if we group all these types of devices into a similar IP address space or similar subnet, what happens is when a computer tries to send some information, it will goes to all the devices in that group. So we don't want to do that. So we want to limit the type of broadcast traffic within some devices or within some IP addresses. So that is another required thing, to have IP addresses in the form of groups instead of scattering everywhere. And the third purpose is security. So IP addresses in a single group or subnet able to talk with each other freely. For suppose you put computers and servers in the same group or same subnet, what will happen is computers and servers will be able to talk to each other freely. For suppose you don't want some servers to talk with any other servers or any other devices, you should isolate them in a separate group, means in a subnet. So we will discuss what is subnet, how computer understand the subnets in the next slides. For now, subnet means grouping IP addresses into for suppose we can take 10 IP addresses into a group, so that the machines in that particular group or subnet will be able to talk to each other, so that we will better organize the IP address space based on the device type or device purpose. Also we will limit the broadcast. Also we can implement security. So when we go to security classes, we will get to know that if you want to apply any security policies, mostly they will be based on the IP address. So if you give IP addresses randomly for different devices, it's not easy to apply a similar policy for all the IPs. So it will be beneficial when you try to implement some security policies to have individual network groups for each device types. Let me give you another example what is exactly this subnet or group, to better understand the subnet concept in the next slides. For suppose let's take a school scenario. A school might have like first grade, second grade, third grade, fourth grade, fifth grade. For suppose let's take an example of first grade. So let's assume there are like 100 students in first grade, and each student will have some unique ID. For suppose let's say we start giving IDs from 1 2 3 4 5 6 until 100. So if we give student, for suppose let's take student number 15, so this is the unique ID of the student 15. So if we tell the student that your unique ID is 15, he knows that his unique ID is 15, but he doesn't know how many students in that class. So to tell him what we can represent this in a way, 15 slash 100, what that means is a student will understand that his unique ID is 15, but in his class or in his group he have total 100 students starting from 1 to 100. Similarly, when you try to give an IP address to a network interface card, you need to give two values. One is IP and another one is subnet mask. So these are the mandatory fields when you try to configure a network interface card of any type of device. Okay, so in this way, so when you try give a computer an IP and subnet, what computer will understand is it will look that IP address and identify it as its own IP address. And when it looks at the subnet mask, it will do the calculation and will identify how many other IP addresses in the same group. Okay, so we will see how we represent the subnet and how computer understands the subnet and identify what are all the IPs in that specific subnet or group in the next slide. So as we learned in the previous classes, we have MAC address and IP address. MAC address is something like serial number and we don't need to configure anything. It will come when the NIC is manufactured. So we don't need to do anything about the MAC address configuration. For the IP address, any network interface card does not come up with an IP. So this is a configurable value and we need to configure it. So when we need to configure an IP address to any machine, you need to give two values as discussed. One is IP, another is subnet mask. So let's take a look. We have two computers. One we want to give IP address 10.0.0.1. For another one we want to give 10.0.0.2. So if we convert these decimal into binary, this is how it will look like. So this value is 2, this is 8, so that it is 10. These are all zeros, so it will be 0. These are all zeros, it will be 0. And the first octet value is 1, so this is 1. So this is 10.0.0.1. And another computer has 10.0.0.2. So this is 2, this is 8. So it will be 10. This is all 0, this is all 0. And this value is 2. So it will be 2. So this is in the binary 10.0.0.2. So how we will specify subnet mask? So we should include something here so that each computer should be able to do some calculation, identify what are other IP addresses in that group. So in this example, we are trying to give an IP address to a machine. So let's call it as computer A and computer B. So when we try to configure, we need to give two values. One is the IP address we want to give for computer A and its subnet mask or group. Similarly, we are trying to give 10.0.0.2 for computer B and its subnet mask. So let's see how computer will understand this subnet mask value. So when you give /24 means what computer will do is from the left to right, okay, it will mask all the 24 values. So here 8 bits, 8 bits, 8 bits, 8 bits, right? So it will lock all these values. That means 8, 8, 24. Here we represented 24, right? So from left to right, it will block the 24 bit values. What does mean by it lock? Means any other IP address in that group should have the same value, same bit value. Okay. For suppose in the first octet, this is the first bit, right? From here, it has 0. Means any other IP address in the same group for the same position, it should have also 0. If you have 0 here, it should have 0. If you have 1 here, it should have 1 there. That means The first octet will be in the same group, will always be 10. The second octet will be 0. Third octet will be always 0. So until this point the values has been locked. The remaining one can be different. So when we looked at the student example, student unique ID is 15 and remaining addresses can be from 1 to 14 and 16 to 100. So here we are locking the first 24 bits, means every other IP address in the same group or subnet will start with 1000 only, and these values can be changeable, so these are not logged. Okay, so let's represent the same thing here, right? So computer A has 10.0.0.1/24, means until this part are same for any other IP in the same group. That's how computer A understands its own subnet mask and IP address. Similarly, computer B, if you see here, these values are remain same when you give /24. So any other IP address in this group will have the same. So in this case, the both bit values 0, 0, 0, 0, 0, 0, 0, 0. If you have 1 here, it also has 1 here. If it has 1 here, it also has 1 here. If it is 0 in this position, this is also in 0 in this position. So if everything the first 24 bit matches, then the computer will know that okay, these two IP addresses belongs to the same group or same subnet, but these values can change. This should not be the same. It can be anything. It could be like anything. No need to match. But for the first 24 should match exactly. So that is the requirement for IP addresses in the same group. So in the same example, let's see what will happen when we give a computer 10.0.0.1/24. As we discussed, it will identify 10.0.0.1 is its own IP address, and the /24, the 24 bit should remain same for all other IP addresses in its subnet. So that means any IP address 10.0.0, and this value can be x anything. So let's see what is the lowest address we can get and what is the highest address we can get. To get the lowest address, we can put all zeros in the remaining 8 bits which are unlocked. So this is the lowest or starting address. What will be the highest using these 8 bits is when we put all ones. So this is 0. When you put all ones, if you include all the bit values like 1, 2, 4, it will become 255. So this will be the last or ending address or highest address. So when we give computer 10.0.0.1/24, it will do the same calculation like this, and it will understand that okay, my IP address is 10.0.0.1, as I have been configured as /24 subnet mask. My group will contain addresses starting from 10.0.0, and it will go like this all the way to 255. So how computer A understands is its own IP address is 10.0.0.1, and there are total 256 IP addresses including 0. Okay, so out of these 256, this is the its own computer IP. When we look at the students example, 15/100 means there are total 100 students, and this particular student unique ID is 15. In similar way, this computer has 10.0.0.1 as its own IP address, and how many total it have /24 means once we do this calculation, we know that total 256 IP addresses, and the starting address is 10.0.0.0, and the next is 1, 2, 3, 4, 5, 6 all the way to 255. Okay, let's look at another example. So now we are giving computer an IP 10.0.0.1, the same IP, but here we are changing the subnet mask to 8. What does this mean is the first 8 bits are locked, and that means any IP in the same subnet should exactly have the same bit values for the first left to right 8 bits. Okay, and the remaining are unlocked, so it can be changed from anywhere. So this is for the dot one. So what computer will do is it will try to calculate the starting address and ending address. So how we will get the starting address is we put everything with zeros. So what it will become 0 0 0. How we will get the ending address? We put all ones. So this is 255 255 255. Means when we give a computer an IP 10.0.0.1 and a subnet mask as /8, it will do this calculation and it will identify that its own IP address is 10.0.0.1, and in this same subnet or same group we have addresses starting from 10.0.0.0, and it will go like that all the way to 10.255 255 255. So there are like so many addresses in this subnet. Okay, so because like if you look at this range, it starts from like 10.0.0.0 and then 10.0.0.1 2 3, and it will fill all the 255, then it will come again like that all the way to 10.255 255. So this is very bigger range. Okay, let's look at another example. Here we are taking same IP, but here we are taking different subnet mask /16. So /16 is the first left to right 16 bits values should be exactly same in any other IP addresses. The remaining 16 can be changeable. So let's calculate this. So 10.0.0.1/16 means the starting address we will get 0.0, the ending address we will get 255.255. As these first two values should remain same, it will be 10 only, it will be 0 only, it will be 10 only, it will be 0 only. So the starting address is 10.0. So these are 16 bits locked, and the remaining 16 bits are starting will be 00, ending will be 255.255. So these should remain same, these are locked. So the only thing you can change is 0.0 to 255.255. So compared to /8, it is little bit smaller compared to that, because in /8 you have 10, this is also not locked. Okay, so you have to do the exact same calculation whenever you try to assign an IP and subnet mask, and if you want to identify what is the starting and ending range, just follow the same procedure. Write down everything in binary and log the bits where you have mentioned in the subnet mask value, and for the remaining ones put all zeros, get the starting address, put all ones for the ending address in that particular group. Okay, so as you have seen, we can represent this subnet mask in two ways. So some devices will accept the subnet mask value in this format, like when you try to configure a network interface card, you can put like 10.0.0.1/16. This is one way. Some devices will require format in this way. So this is also same thing, but the representation is different. /16 means these 16 bits, right? So 8 bits and 8 bits. So if you put all ones, what is the value? 255 255. So what does 255.255 means here is, when you convert this into the binary, how many bits you need to need if you put once is 16 total, right? So this is another way to represent. So don't confuse how we are representing this. As long as you understand the concept of locking the bits and able to recognize what is the starting and ending address, that will be enough for this class. Okay, so now I took a different example. Okay, so now 10001 slash 30 means from left to right 30 bit values should be exactly match. So here 8 8 8 8 8 8 total 24. Here you have 8, but we are locking until 6 bits only. These 2 bits you can change. Okay, so what will happen? So let's identify the starting and ending for this one, right? So starting, this is 10, this is 0, this is 0, should exactly match, so this will also become 0. But in this case, what is the possible scenarios is these are all zeros. Okay, sorry, I did a typo here. This should be all same zeros. Okay, so only these two can change. So to get the lowest value, it will be, you will put zeros and it will be 0. Highest value you can put all ones. So in this 2 bits you can put ones. So this value is 1, this value is 2. So total 3. So the range of this IP address space is starts from 10,000 and it will go to all the way to 10,003. So that means what, how many IP addresses it has? Simply 10,000 first address, and the next one is 1, another one is 2, another one is 3. So there are only total 4 IP addresses in this subnet. Okay, so this is a smaller subnet compared to the previous examples, because here we only have 4 IPs in this subnet. Okay, so let's look at this format. So what does exactly 252 means is 255 means, how do we get 255? You put all ones, 1 2 3 4 1 2 3 4. Okay, then another 255, 1 2 3 4 1 2 3 4, 252, oh sorry, another 255, and here 252, all 8s, 1 2 3 4 1 2 3 4. So here, as it is /30, you should only count until this part. Okay, so what are the values of this one? 4 1 2 4 8 16 32 64 128. If you add all of them, it will become 252. Okay, the simple way to calculate is, instead of adding all together, you know that the everything total, if you put all ones, is 255, right? If you remove these two values, you will get this value. So this is 1, this is 2. So if you remove 3, it will be 252. Okay, so when you represent IP address and net mask in this way, that means is the first 30 bits are locked. Either you can direct for some devices you can directly configure like this /30. For some devices they will have only accept in this format. So when you want to represent /30, you should start writing ones all the way from left to right 30, and then calculate the value of that binary into decimal. So all these 8s, 8 8 6, so this 8 will become 255, this 8 will become 255, this will become 255, and the last one will become 252. So this is how you represent IP address with a subnet mask. So you might have to go through this class couple of times to understand it better. It might be confusing for the beginners, but yeah, as you do so many examples, you will get used to it and you will be easily identify when looking at a IP address and subnet mask. Okay, so practice more. So assignment for today's class is I have given 3 IPs with their subnet mask. So you have to identify what is the starting and ending address for each one. Okay, that's all for today's class. And so far we have done theory part. So these are the very basics to start doing any labs or to learn actual networking. So from the next class we will have labs. So for labs I will use a software called GNS3. So it is a free software and you can install it on your PC to practice the labs. It might require some network devices in the future labs, but yeah, for now install GNS3 to perform the next couple of labs. That's all for today, and we'll talk to you in the next class.